The boiling point of alkanes increase with increasing molecular weight. For example, if you look at the methane, the molecular weight of methane is 16 gram per mole, while butane 58 gram per mole. The boiling point of butane is much higher than methane because the bigger the molecular weight, the larger the surface area. So, the stronger intermolecular van der Waals forces exist between its molecule, more energy is needed to overcome the forces. That's why butane will have higher boiling point than methane. Alkenes that have comparable molecular weight, or if we have an isomeric alkanes such as 2-methyl propane and butane, so both have 4 number of carbon, okay, the molecular weight are the same, okay, so if you look at the boiling point of butane, so butane has higher boiling point than 2-methyl propane. This is because the presence of branch in the 2-methyl propane makes the surface area smaller. So less van der Waals forces that can be formed between 2-methyl propane molecules. So weaker intermolecular van der Waals forces exist between the molecules. Less energy is needed to overcome the forces. That's why butane has higher boiling point than 2-methyl propane. How about the boiling point of straight chain alkanes and cycloalkane? For example, here if I have cyclobutane and butane, so these two have comparable molecular weight, but the boiling point of cyclobutane is much higher compared to butane. So this is because in cyclobutane, okay, cyclobutane is in a planar structure. So all the cycloalkanes are in planar structure. So it has a larger surface area compared to a straight chain alkane. Okay, so stronger intermolecular van der Waals forces exist between the molecules in cycloalkane, so that's why more energy is needed to overcome the forces. Cycloalkane has higher boiling point than straight chain alkanes if the molecular weight are comparable. But if our straight chain alkanes has bigger molecular weight compared to our cycloalkane, it will has higher boiling point than our cycloalkane. So for example here, pentane has 72 gram per mole, but cyclobutane only has 56 gram per mole. So since pentane has bigger molecular size, its surface area is larger compared to cyclobutane. Thus, stronger intermolecular van der Waals forces can exist between pentane molecules. More energy is needed to overcome the forces. That's why the boiling point of pentane is higher than cyclobutane. Let's have a look at this example. So arrange the following alkanes in order of increasing boiling point. Explain your answer. So if you are given the structure of the compounds only, okay, so first thing first, you must calculate its molecular weight. Alright, or if you have an alkanes compound, okay, it's just enough if you calculate the number of carbon, because since we know as the number of carbon increases, the molecular weight of the compound also increases. So in this case, we can see that only this compound got 7 carbon, the other 3 got 6 carbon. So the one that got more carbon has the biggest molecular weight. So to arrange the compound in order of increasing boiling point, so we know that as the number of as the molecular weight increases, the boiling point also increases. So the one that got biggest molecular weight will have the highest boiling point. So in this case, this compound will have the highest boiling point. So I'll just label it as A, B, C, D. So since this one is the highest, I'll label it as compound D. Right? So I'll put D here, and then for these 3 compound, it has a comparable size. So the one that have a cyclic structure will have the highest boiling point. So the cycloalkanes will have highest boiling point compared to the straight chain alkanes. So I'll put this one as compound C, right? And then between these two compounds, branching will decrease the surface area and will make the boiling point lower. Alright, so this one is going to be my compound A, and then this one is my compound B. To arrange it in increasing order, so we have A, B, C, D. To explain our answer, so first we are going to state the type of intermolecular forces present between the molecules. Okay, so since we have alkanes compound and cycloalkanes, so alkanes have a very low polarity. So the type of intermolecular forces present between the molecules is only a weak van der Waals forces, which is the London force. Next, compare the boiling point between the compounds. Okay, so compound D has the highest boiling point. Okay, we said D has highest boiling point because it has the biggest molecular weight. So when the molecular weight is the biggest, so of course it will have the largest surface area. So a stronger van der Waals forces will exist between its molecules. So that's why we need more energy to overcome the forces. Right, so that's why D has the highest boiling point. Next, we are going to compare the boiling point of this comparable molecular weight compound, which is A, B, and C. Okay, so boiling point of compound C is higher than A and B because C is in planar structure. So we know that cycloalkanes are in planar structure, so it will have a larger surface area. And then when the surface area is larger, it will form a stronger van der Waals forces between its molecule. So more energy is needed to overcome the forces. That's why C has higher boiling point than A and B. And last but not least, compare the boiling point between compound A and B. So, since the presence of branching in compound A will reduce its surface area, so weaker van der Waals forces will exist between its molecules. So that's why less energy is needed to overcome the forces. So the boiling point of A is lower than B. For the solubility of alkanes, we are going to have a look at its solubility in water and also in organic solvent. So in water, since water is a polar solvent, while alkanes have very low polarity due to the presence of only carbon and hydrogen atoms in its molecule. So we know that the difference in electronegativity between carbon and hydrogen is very small. So that's why it has very low polarity. So it cannot form hydrogen bond with water molecules. So that's why alkanes is said to be insoluble in water. But in organic solvents such as CCl4, benzene, chloroform, alright, alkanes are soluble in most of organic solvent of low polarity. Explain why butane is insoluble in water but soluble in carbon tetrachloride. So since butane has very low polarity and it cannot form hydrogen bond with water molecules, which is water molecules is a polar solvent, so that's why it is insoluble in water. But in carbon tetrachloride, okay, so carbon tetrachloride is an organic solvent which is a non-polar solvent. So butane can form van der Waals forces with carbon tetrachloride molecules. So that's why it is soluble in carbon tetrachloride.